Hi, class. Um, Hopefully things have been going well for you and you've been staying healthy. With distance learning, my my plan is to get back into where we left off and actually rewind a few days, dealing with starting with our introduction to chemistry. You can follow along in your textbook on page 345 of your textbook, chapter 10. We'll be going through the textbook. And so my objectives for this lesson for first is, can you define what a substance is? And a substance, when you talk about a type of thing, you're talking about a substance. And then substances are made up of atoms, and so we talk about how different atoms differ from each other. Myself in the camera. How do mixtures differ from substances? So you can actually mix substances together and make mixtures. And then how can we classify matter? First, what is matter? Well, matter is anything that has mass and take up space. Whether it is I guess my picture here, false teeth, is made of atoms and has space. The room inside the mouth is taking up space. Another term for taking up space is it has volume. And so hammers here, bulldozers, tools here for the solids. Those are all types of matter. And then here in the middle are liquids, and there's a lot of waters in this picture I chose here. And there were bathtub water, drinking water, sink water, snow, melted water, beach water, soup, cocoa, coffee, all have water in them. But water's not the only liquid. It could be mercury at room temperature, which is a metal. There's a lot of liquids out there. Oils and then gases. The air you breathe. Does that matter? Well, the air you breathe is actually made up of atoms, and so yes, it is matter. A lot of oxygen atoms, a lot of nitrogen atoms. Water vapor. When you boil water, it turns from a liquid into a gas. That gas is matter. What isn't matter? So here you're going to try and distinguish between what matter is and what matter isn't. Good luck. Hopefully you did okay on that. On what is matter, what isn't matter. Matter has made up of atoms. Is light made up of atoms? No, light is not made up of atoms. Light is energy. And space without matter in it, space without atoms in it is not matter. It has to have the atoms in there to make it matter. What is an atom? Atoms are small particles that are the building blocks of matter. They're made up of three building blocks, two of which are inside the nucleus of the protons and neutrons. Those are really where all the mass is. There's just a tiny bit of mass in the electrons, and we don't actually necessarily calculate into the mass of the atoms. The mass of the charge of the protons is positive, shown by that positive symbol on there, and the green circles are in the nucleus, and also in the center nucleus are the blue neutrons. Those don't have a charge, thus we call them neutral neutrons. And then the different rings in this type of model are the negative electrons, and those whip around, vibrate around the nucleus at different levels. And in this case here, it looks like we have 6 electrons. So probably making there. I can only see 5 protons, but probably 6. There has to be 6 and one hidden that we can't see. So if it has 6 protons, what you do is you look on the periodic table or the number 6, and that'll tell us what element this is. And we'll talk about periodic table quite a bit in future lessons. A little bit today, a little bit more today, but really in the next chapter. So a substance, that is a substance's matter that has the same composition always. So if you're talking about water, water is water. It has the same composition regardless how we if it's water with Kool-Aid mixed into it, that's no longer the same substance. But water is always water. Elements are always elements. So compounds and elements. What is an element? Well, the periodic table, this chart here is one of the most fundamental, useful charts of all time. This tells us so much, tells has all 118 different elements on it. But with this chart, we can tell how reactive each of these are, what type of form they'll be in, what they'll look like, and a lot more. And on this, there are 118 different elements, but only 92 of them you can find in nature. Those above that have been created by humans in laboratories. Then we combine elements into molecules to make compounds. Or like we put one hydrogen, another hydrogen with oxygen, making water. Got there is sodium and chlorine, making table salt. So mixtures, then another type of matter is a mixture. Mixtures is matter that can vary in composition, where we mix things together. The first is like trail mix, or that cookie, I think that's a rock that has that rock, that trail mix has different parts of it are different from each other. Where a homogeneous mixture, where it's evenly mixed, where it's the same throughout. It is salt water. It's a mixture of salt and water, but it is salt water, evenly mixed throughout. Anyway, mixing those things means we dissolve them into it. And dissolving means that we mix two things together and form a solution. Now, that's another term. What is a solution? Well, a solution is a combination of a solvent and a solute. 2 more terms. But Kool-Aid there is a solution. And the water there is a solvent. That's the thing that does the dissolving. And the sugar in this case, or the Kool-Aid pack, as it gets put in there into the water and gets dissolved by the solvent water, makes a solution of the Kool-Aid you can drink. Here we have Tim Moby. Let's see if we can watch this.
Can't solve cube puzzle. Getting angry. Thank you. Dear Tim and Moby, what are mass, volume, and density? And why are they important? Love, Kira. Mass, volume, and density are all physical properties of matter. Matter is anything in the universe that takes up space. It makes up everything that you can see, feel, taste, or touch. And mass, volume, and density are measurements that we can take of material objects. Why do we measure stuff? Well, basically to understand it better and to compare it to other stuff. For example, we measure time in hours, minutes, and seconds. Can you imagine if we had no way of measuring time? We wouldn't know when to go to school, when to come home, when the next episode of Battlestar Galactica was on. And if we couldn't measure the mass, volume, and density of objects, we'd be just as confused about what they are and why they act the way they do. Right, measurements also help us standardize stuff. In the science lab, we use the metric system for all our measurements. Its basic units are the meter for length, the liter for volume, and the gram for mass. Because the metric system is used all over the world, scientists everywhere can compare their discoveries and ideas without too much confusion. Now, let's measure this cube. We'll start with its mass. Mass is a measurement of how much matter an object contains. In a lab, we measure it with a balance or a scale. Let's see, the cube's mass is about 250 grams. Well, weight is different from mass. Weight is actually a measure of the effect gravity has on an object, and it's measured in newtons, not in grams. For example, on Earth, this cube weighs 2.5 newtons. But on the moon, where the gravity is only 1/6 as strong as Earth's gravity, the cube only weighs 1/6 as much. No matter where it is, though, the cube's mass is always the same, 250 grams. Now to volume. The cube's volume is a measure of how much space it takes up. Since this object is a solid, the volume is measured in cubic centimeters, and you can calculate it by multiplying its length by its width by its height. Well, liquid volume is measured in liters. 1 milliliter takes up the same amount of space as 1 cubic centimeter. And while it's easy to measure the volume of a cube, it's a little more difficult with an irregularly shaped object like this pebble. Matter displaces liquid, and that's a fancy way of saying it takes up space. If you can measure the amount of liquid that the object displaced, then you've found the volume of the object. Before we dropped this rock into it, the water had a volume of 50 milliliters. After we dropped it in, the water level rose to 70 milliliters. So we know that the pebble has a volume of 20 milliliters, or 20 cubic centimeters since it's a solid. Density. Density measures how heavy something is for its size. Are its atoms packed close together or far apart? We can calculate density by dividing an object's mass by its volume. Let's see, the mass was 250 grams, and the volume was 1,000 cubic centimeters. 250 over 1,000 is 0.25. So the density of this cube is 0.25 grams per cubic centimeter. Pretty impressive, huh? Okay, now you're just showing off.